In this video and the next two videos, I'm just going to be introducing and showing really just calculus now with trigonometry and specifically differentiation. So, you had your fun with chain rule and all these stuff and all the other things you've learned, and now it's time to apply it to trig, because why not, right? More stuff is more fun, right, in math? I'm sure you feel that way. Anyways, so before we begin into understanding the derivative of certain functions, like, what's the derivative of sine x, right? There are these two important limits we need to understand, and I've written them out for you already. It's the limit of x approaching 0 for sine x over x, and the limit of 1 minus cos x over x. Both of these limits are pretty important to know because they can help us understand how we get the derivatives for the other trigonometric functions. So to begin with, in this video, I'm just going to be actually focusing on this guy. In the next video, I'll be talking about this. So right now, this is the main priority for this video. So let's get right into it. So intuitively, if we look at the graphs here, actually for both, I'm going to briefly talk about both actually. So here we have the graph of sine x over x, and here we have the graph of 1 minus cos x over x. Intuitively, we can sort of see that, well, as the limit of x approaching 0, right? As the limit of x approaching 0, we can see that it equals that value. Now, obviously, there's a hole here, it'd be undefined, but we can see that as it approaches, as it gets infinitely closer to, it basically just becomes 1, right? Looking at the limit of x approaching 0 for 1 minus cos x over x, we can see as it's approaching 0, just by looking at the graph, it's getting closer and closer to this value right over here, right? So it's getting infinitely closer to 0. So that's how we get that. So it makes sense intuitively, but what's the algebra behind it? So like I said, this video is just going to show for the limit of sine x over x. The next one we'll talk about 1 minus cos x over x. So format it correctly, looks nice. All right. So what I did here was I drew a nice little unit circle, right? And this very interesting looking triangle thing, right? That's been sort of split up. So basically, let's just compare some areas real quick. And I forgot to mention this, but I'm basically just going to be showing the proof of why sine x over x equals 1. So let's just compare the areas. So what I did here was I used the unit circle. So we know that it has the radius. Yikes, that's a terrible curly bracket. We know that this has the radius of 1, right? And we know that, well, this up till, here is also 1. So that's not a 1 at all. Good Lord. All right, there we go. Okay, formatting. So I've drawn this triangle here. So we know that the base is 1. So all of these have a base of 1, right? 1 unit. Now let's say I ask you to compare the areas. So here we have a triangle. Here we have a sector. And here we have another triangle. Now a sector is just a chunk of a circle, or like a wedge. So this actually looks like a nice, pizza slice out of the whole circle, right? So this area here, this small triangle is represented over here, this whole thing. This is the area we're talking about. And then for the sector, this is actually just like this. So it's touching this white line. As you can see, that is the sector. And then lastly, if you wanted to know the big triangle, here's the big triangle. All right. So that's basically it. I just sort of took it out to show it to you so it makes more visual sense. So I've split up my triangle this way. Now let's say I asked you to, to compare the area. So hopefully you can tell, just intuitively, in terms of the area of this, it's going to be less than or equal to area of this, which is going to be less than or equal to the area of this, right? So this triangle here has the most area, this has the least area, and this is in between them, right? Now, and it depends on the angle x we have here. So how would we describe the area in terms of, the formula? So the area of the formula for a triangle, right? The area formula is just base times height divided by 2, right? So let's look at this yellow small triangle first. So we know the base is 1 here, right? So we're going to have 1. So I'll just write the half here. So we'll have 1, and then we're going to write a half. Sorry, half, and then a 1, right? Now what's the height? Well, this nice little sparkly line here signifies the height of this triangle, and we can determine that through some basic grade 10 trigonometry. X, right? Opposite of x is the height, so we could think, well, I know the hypotenuse, which is 1 here, so I could say this is just, if I did sine of x, right? Opposite over hypotenuse. Opposite is this unknown, right? The sparkly line over 1. So then the height, or actually I should just write this as h, right? So then the height actually just equals sine x, right? Because that's 1. So the height here we know is now sine x. What about the sector? So the area of a sector, the formula is actually the angle multiplied by the radius squared over 2. So in this case, we know x, right? Oh, I'm sorry, we don't know x, we just write x. And then r squared, well, we know the area is just 1, so that's 1 squared, that just gives us 1, so we don't have to write that. And then we get x, well, all over 2. So that's how we would express the area for this sector. Now let's say we express the area for this triangle. So this green symbolizes the height. This is the height here. And from basic trigonometry, from grade 10, trig, we can see that, well, this could just be tan x, right? Because tan x is opposite over adjacent. So this would be opposite over adjacent, and adjacent is just 1. So this just becomes tan x. So the half, the base is still 1, right? 1 times tan x. All right. And then I'll just erase this to make sure we have some space. All right, so now just multiplying it all, we get half sine x less than, I'm just gonna write this as half x less than half tan x. All right, let's just do some basic algebra. I'm gonna multiply everything by 2 so the 2's cancel out. So now I get sine x is less than or equal to x, which is less than or equal to tan x, right? Now what we're gonna do is, let's say I wanted to divide everything by sine x. So I divided everything by sine x. Okay, I get 1, I get x over sine x. Maybe you see where we're going. Now, hopefully, you know your trig well enough. Tan x is just sine x over cos x. So when we're dividing by sine x, right, we're just visually, I'll just do this extra step to be as clear as I can. Right, take the reciprocal, basic math you already know, this just becomes 1 over cos x, right? So tan x divided by sine x, this is just 1 over cos x. Now, let's think about what we can do here. We want to end up getting sine x over x, right, to show this proof. And I didn't explicitly say this, but we did this inequality for a reason, because we're going to use something called the squeeze theorem, and it's going to make sense in a second. But basically, since we want sine x over x, we have an x over a sine x here, we can just take the reciprocal of everything. So when we take the reciprocal of this entire inequality, the sign changes. So it goes like this. So this becomes 1, and this becomes sine x over x, and then just this becomes cos x. Now, what is the squeeze theorem? So I'm going to write on the side here, squeeze theorem. What the squeeze theorem allows us to do is this nice little way, at least from my understanding, of just finding out limits of stuff, right? You can find the limits for things in the middle. So if you, like, intuitively, it doesn't make sense if, like, well, if you didn't look at the graph and you just said the limit of sine x as it approaches 0, you would just say that's undefined, right? But that's actually not the case. It's not undefined. That's not how it works. And so what the squeeze theorem tells you is put it in a place where the thing you're interested in is in the middle. So there's a function in the middle. So I'll write function in middle between two other functions, right? These are functions, so I'm just gonna write f. And then what you can do is you can take the limits of both sides and see what you get. So let's take the limit of 1 here. So I'll just write it like this. So I'll take I'm going to be taking the limit of x approaching 0 of 1 is greater than or equal to the limit of x approaching 0 of sine x over x greater than or equal to the limit x approaching 0 of cos x, right? Now, the limit of x approaching 0 for 1, well, there's no x value, so this just remains 1. The limit of x approaching 0 of sine x, right? Now, again, we're just substituting it in. So the limit of x approaching 0 for cos x, if you just cos 0, just gives us 1. So this becomes 1. Now we have an interesting situation. We basically have this parameter where we're saying, well, the limit of sine x over x is less than or equal to 1, but also greater than or equal into 1. So hopefully you can see this idea of the squeeze, because what possible value could exist between these two conditions? It is greater than or equal to 1, and it's less than or equal to 1. What can it be? Well, it can only be 1. Not factorial, but it can only be 1. So therefore, right? Hopefully that makes sense, because it's squeezing, you know, think of it like this. We're squeezing it in if the conditions are the same so that this becomes 1. So therefore, the limit of x approaching 0 of sine x over x equals 1. That is a visual proof turned into an algebraic proof that hopefully makes sense to you. So it just really used something called a squeeze theorem, which is new to you. And yeah, hopefully this video helped. The next one will show the limit for the other one, which is 1 minus cos x over x, which will be an easier one because we're just going to be using the sine of x over x limit as x approaches to 0. But yep, that's pretty much it.